Okay, I'm going to whip through this. Some of the stuff that's in your book I am not going to do. I am not going to bother with anything to do with algebra tiles. Some of you have seen them before. I don't think they have a lot of use, so I'm not going to be doing anything with them. 119. A polynomial is an expression. Now, guys, when I use the word expression, that means something. And I'm going to highlight this area over here yellow because this is expression, the definition thereof. 119.
He said it like 10 times.
Then you should move to the front where you can hear my very quiet voice better.
You're not a soft-spoken person, are you?
No. Which is why I get very bothered when people hand me the line of horse crap that they can't hear me. What they really are saying is, I'm not listening to you, Mr. Myers, because other things are more important, like the earbuds in my ear and the crap that my friends are saying.
What earbuds?
Uh-huh. Expressions are the following. This is an expression, 2x plus 7. Why is that an expression? Because there is no answer. That is an expression. There is no answer to that. You cannot find an answer to that because it is an expression. An equation that has an answer. So that is an equation. An expression, at best, is something you can simplify. Okay? So a polynomial is an expression. There is no answer. Back to work on it. A polynomial is an expression consisting of coefficients, variables, and constants. Okay? It can have some or all of those three things. Okay? Here is what it cannot have. No fraction exponents or irrationals. Okay? Irrationals. No fraction exponents or irrationals are allowed. So, just to make sure, does everybody know what a coefficient is? We already talked about that in radicals. Everyone knows what a variable is. What is a constant?
X.
No, x is a variable because you don't know what it is. 2 is a constant. Why, Avian?
Because there's no variable.
It's 2. How many pencils are in my writing utensils are in my hands? 2. That's a constant. There are always 2. If there are 2 things there, they are 2. Okay? Now how many pens are in my hand?
Unknown.
Unknown. So that's a variable. Yes? Now I have 2 hands behind my back. So how would you write that?
2x.
2x. Because I have 2 hands. Each is holding an unknown amount of variables. So it is 2x. Right? Okay, good. Yay, everybody understands constants, variables, and coefficients. Good. Now, you don't need to write this down, just making sure you get it. Is that a polynomial? Which is it? You can't just say yes and no and wait. Make a decision. Is that a polynomial?
No.
Why not?
Because there's no
Read the definition again.
Actually, that.
It's not. It is.
Yeah, some are all. So
Excellent. So that is a polynomial. Good.
yeah. That's
Excellent.
monomial.
Well, we're getting to that. That is a polynomial. That's where we are right now. What about this? 3x squared.
No,
Yes, it is.
That's good. Yep, that's okay. So that's good. That's good. What about this? 4x squared root.
No.
no,
No.
no.
Yeah, it is. Why, Ekdeep? Isn't that 2x? Square root of 4 is 2. Square root of x squared is x. So that's okay, because that's not irrational. What about this? No, why not? It could be irrational, because that is technically x to the 1/2, yes? Fractional exponents allowed? No. Everybody good? Sweet. Let's carry on. Monomial is a single variable, constant, or coefficient. A single variable constant. I'm not talking about Scrabble. Constant or coefficient expression. So, it can be a variable, x. It can be a constant, 7. It can be a coefficient, 3x. Everybody cool? Everybody good? Okay. Sydney. Everything's a polynomial, but a 2 is specifically a monomial. Okay? Everybody good? All right. So that's a monomial. A binomial is 2 monomials. Like a bicycle is 2 bicycles. 2 monomials separated by plus or minus. Everybody cool? Yeah? So, here's an example. X plus 7. Yeah? Okay. Here's another example. 3x plus 7. Yeah? Now, I'm going to ask you, 3x plus x, is that a binomial? No, why? Nope. Nope. What's 3x plus x? No. 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 Getting warmer. 4x.
Because there's no 1 in front of the x 3 times.
Say it louder.
Oh, well,
Everybody else was screaming the wrong answer 25 times, like Amrit back there. So that, we would never leave it that way. Okay, next question. Is this a binomial? 4xy. No, why?
There's no plus or minus.
No plus or minus.
Yeah.
Excellent.
So smart.
That's one word for it. Why? Why do you think that's ripping on you? There's lots of words for smart. Clever, intelligent, sharp,
Now you just want more.
astute.
Wait, what? That just sounds astute.
Astute.
I'm so astute.
You said you're so smart. I said that's one word for it. I just gave you 4 more. It's not my fault that you think that I'm bugging on you.
No, I don't.
That's your conscience. That's your hang up, not mine. I'm complimenting you.
Sorry.
A trinomial is 3 monomials. Separated by plus or minus. So 3x squared plus x plus 7. Okay? Okay. Now, this monomial is also called a term because it's one single monomial. Term equals monomial. I didn't spell that right. Monomial. So, trinomials have 3 terms. Now, the thing that people have trouble with is always this. 3xyz. A bunch of you are going to tell me that's a trinomial. Of course it isn't. That's a monomial because there's no plus and minus. Then I do this. Negative 3xyz. Still not. Because that is not the math, addition and subtraction. That is negative and positive. Okay? Okay. And finally, for polynomials, the degree. This is really not important until later on in math. And it's only important because it's the way your math professors will want it written. Okay? It's just agreed upon by math people that this is what we do. The degree of polynomials is the sum. Please highlight sum of all exponents. Oh, I should have written greatest. Damn it. The greatest sum of all exponents in any one term. So, 3x squared plus 2x plus 7. What is the sum of the sum of the exponents in any one term for variables? So, what is the degree of that one? 2. Because this term has an exponent of 2. There's no other variable, so I don't need to add it up. So that is a degree 2 polynomial. Okay? What is this one? That is 2 as well, because that has 1 and 1. 1 plus 1 is 2. Everybody cool? That's still a degree 2. What is this one? 3. Because that's 3 plus 1. Okay? Now, the only reason that's important is this. We write our polynomials in descending degree, so biggest degree first, and exponents of x. So we also put them alphabetically. All right? I don't care about that in grade 10, but you should be made aware of it. So if you came up with this answer, don't write this down. 3a squared b to the 4th plus 2a cubed b squared minus 6a squared. If that's what you finished up with, technically, that might be right, but we like to write it in alphabetical order with the biggest degree first. So what's the first letter there? A, right? And this guy has no B's, right? So some math teachers will say put the A first and then do all the extra letters, right? So you could write this as negative 6a squared. Then what would be next? 2a3b squared, because the biggest degree goes first. I'll get to you in a sec. Plus 3a squared b to the fourth, because we want them in order of degree with the first letter. Okay? I don't care. Don't worry about it. All right? What does I don't care, don't worry about it mean? There you go. See how you can answer your own question before asking it? By listening to what I have to say? There you go. It's there to make you aware of it. Yes. All right. We are not going to do, well, I'm going to show you it once, because some people actually like these things. I don't. This means I have the monomial 5, and I have the binomial x plus 1 as a binomial. Now you think back to grade 3 when Mrs. Bag Crumble was teaching you how to multiply. Andrea has 3 apples. Navnor has 3 apples. Gurmuk has 3 apples. How many apples do they have? 9. Because you had 3 apples times 3 kids to make 9, right? So this means I am taking that binomial and writing it how many times? 5 times. So there would be 5 x's and 5 1's, right? So the answer is 5x plus 5. Now, if we draw this out, the new way we like to teach people math is we like to use these symbols. That means x, that means 1. And there's 5 of them. 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 x's plus 5. And then we make this little stupid box around it, which is wonderful and useful for doing anything up to squared. In math, do we sometimes have exponents bigger than 2? Yeah. So does this have a lot of use for us? No. But they make us teach it to you anyway. There, you've seen it. Okay? I don't want you to ever use them again. All right? Ever.
I hated that. Thank God. It was a waste of time.
No, it's not a waste of time. It's very useful for a couple of things. For example, what's negative 3 minus negative 5? No. See?
Positive 2.
There you go. That's why algebra tiles are useful, because then you people could finally maybe understand subtracting negative numbers. Maybe.
Negative and negative.
Yes, and yet every time I ask that question, you guys can't give me the right answer. What's negative 7 minus 4?
Negative 7.
Minus 4.
That's negative 11.
Yeah, negative 11. Took a long time to do that.
Well, I didn't hear you that way.
I know. I'm quiet. We've been over that. Okay. Now, here's what you're actually going to do, which you've already been doing all along. You're going to do this algebraically. 5x plus 1. That means 5 x's plus 5 times 1. Since you don't know what that x is, you have to leave it as 5x, but you know that 5 times 1 is 5. Okay? A lot of teachers have a lot of fun little names for this. Okay? I don't. Why? Because I don't give things fun little nicknames. I call them what they actually are. The distributive property. Ax plus y. That is ax plus ay. That math right there is times. I don't want to write an x because I've been writing x's. That is multiply. That is multiply. A lot of teachers, when they teach this to you the first time, will draw these fun little arrows and they will give it a fun little nickname. I will not, because it is called distribution. What I will tell you is that this term out front, the leading coefficient, must multiply by every term in the brackets. Just like when you add an exponent outside of brackets. So since you all already know how to do this, you do not need to draw a picture of it, but I do want an algebraic solution of this. X times 2x minus 4. That x is a leading coefficient. Even though it's a variable, it's still a coefficient because it's the coefficient of this expression. So it goes in there, 2x squared, and then it goes to there, minus 4x. Okay? I know it's easy, and yet people can't do it. Let's do this one. 3x, x plus 2. What do you get? 3x squared plus 6x. Excellent. Now, do this one. Negative 3x, x plus 2. Negative 3x squared minus 6x. Now do this one. 3x times x minus 2. 3x squared minus 6x. Then do this one. Negative 3x times negative x minus 2. Three x squared plus 6x. Excellent. Or is it violent? Excellent. X. We often use y as a variable. Violent.
He's not very astute, you won't understand.
Wait, how do you say that word for smart again?
Astute.
Astute.
A-S-T-U-T-E. Astute.
You're not very astute.
All right. You need not write this down, but I am going to show it to you just once. X plus 3. There's an x. There's 3. You're going to multiply that by this side of the rectangle. X plus 2. X, that rectangle, is being stretched out there to make x squared. There is 1, 2, 3 of them there. 1, 2 of them there. And then 1, 2, 3, 4, 5, 6 of the little guys to get x squared plus 5x plus 6. Right? To do that algebraically, x plus 3, x plus 2. What is happening algebraically here is very important. If I had x times x plus 2, what would the answer be? It would be x squared plus 2x, yes? Okay. And if I had 3 times x plus 2, what would the answer be? 3x plus 6. What do you see right there? Like terms. 2x's and 3x's make 5x's. Okay? What you are doing here is actually distributing that x, just like you knew how to do it, and then distributing that 3, just like you knew how to do it. But math teachers, often math teachers that are in elementary and middle school, give you this little shortcut without telling you why it works. That little shortcut is FOIL. I don't like to use it, but all of you have heard of it. So that's why I use it. What is actually happening here is this. First, which up here is x times x. Outside, which up here is x times 2. Inside, which up here is 3 times x. And last, which up here is 3 times 2. Now, there's so many ways to do this. I personally like showing you actual distribution. So when I am doing questions that require this type of thing, which is polynomial times polynomial, and I get that question, I'm going to rewrite it again, x plus 3, x plus 2. This is how I like to show my work. If you do it always the way I'm about to show you, it will work no matter how complicated the polynomials get. All right? Here is what I like to do. I still use FOIL, but I don't memorize it as FOIL. I use that as my roadmap to solving the problem. First, x times x, x squared. Outside, x times 2, 2x. Now I am done with this term. Now I got a new term, so I'm going to start a new line. So first I did this, and that's written in black. Then I got a new term, so I'm going to write a new line. My first term is 3x. I write it with the other x. And then my last term, 3 times 2, is 6. Then my like terms are already lined up. Then you can't screw it up. X squared plus nothing is x squared. 2 plus 3 is 5x. 0 plus 6 is positive 6. Okay? Why do I show that to you? Because just like exponents go bigger than 2, polynomials get bigger than binomials, don't they? So if I gave you this, x plus 2 times x squared plus 2x plus 4, and I asked you to multiply that out, does FOIL work there? Is there first, outside, inside, last? No, because there's a middle term there. So memorizing FOIL won't help you, but learning what FOIL is doing will help you. And what is FOIL doing? It is doing distribution twice. FOIL distributes this x all the way through here, and then it distributes this 2 all the way through there. That is the point of what you are doing. It is not FOIL, it is distribution until every term has been distributed. Okay? So if you were doing this question, your first answer would be x what? Cubed. Your next term would be what? 2x squared. Your next term would be what? 4x. Now I'm starting a new term, so I'm going to write a new line. What is the first term in green? 2x squared. I already have some x squareds, so I'm going to put the x squareds with the original x squareds. What's my next line? 4x. I've already got an x, so I'm going to put them there. So x's are with x's. And what's my last line number? 8. Now it becomes super easy to collect my like terms because they're already lined up. Do you have to do this? No. But I have found in 20 years of teaching, this really helps kids when the polynomials that you are multiplying together get bigger. Use it, don't use it, I don't care. It's up to you. So the answer is, of course, x cubed plus 4x squared plus 8x plus 8. Okay? What if I gave you trinomial? How many lines would you have? 3, because there's 3 terms at the beginning. What if I gave you 4 terms and 4 terms? You'd have 4 lines, and they would just line up all the x's, x squareds, and whatevers. Okay? Use it or don't use it, it's totally up to you. So now I want you to show me this. If I'm going to multiply that out, I need to do that x to both terms. What are they? X squared and 4x. Then I need to do that term to both terms. So what's that? Minus x, keeping the x's together. Minus 4, keeping the constants together. Then I would add it up. X squared, 4 minus 1, plus 3x. 0 minus 4, negative 4. And I'd get it. Everybody cool? Now, there is another shortcut. Something you can memorize if you know what you're doing. If you are comfortable with this, then there's something you can use to help you when it's variable plus constant. If it's variable plus constant, there's a little trick. Please notice. This is variable plus constant, yes? The middle term, negative 1 plus 4. Right? So x squared. And then the middle term is add the constants. And then put x. And the last term is multiply the constants. So notice here, when we did it all out, we got the answer. But because we started variable, you could have used that shortcut. Negative 1 plus 4 is 3. Negative 1 times 4 is negative 4. Everybody cool? I only want to show it to you once because I don't want you using it unless you're really, really good at actually doing algebra. Okay? I'm almost going to shut up. As a matter of fact, I am going to shut up. On page, your homework tonight is 122 to 124. Now listen to me. You have a test tomorrow, yes? Okay. You may finish that test early so you could work on some of this tomorrow, yeah? All right. It is 12:05. I want to mark pages 150, 113, was it? 114 to 117 by the end of today. Today ends at 1:10. I want 20 minutes to mark that, giving you 45 minutes to get that done. That is enough time if you work. I have noticed this is what the graph of work this year looks like. First 3 days, this was time, this was work. As time went on, work went down a little bit. More and more, less work in the same amount of time. That was week 1. Week 2, okay. I don't like that. So when I say it's work time, we are working. Any questions? 45 minutes to get those 4 pages done. I've given you lots of time today. 1:14, 15, 16, 17. That is due today in 45 minutes. I've given you lots of work time this block, or this day. Page 122 to 124. Listen to me, please. I am going to finish them right now, and I'm going to add them to tonight's video. You may check your work on it. Tomorrow, if you got questions, you can come to me. Yes. Amrit, you can go get a drink now. Everybody good? Go. Oh, and you don't have to do any pictures on 122 to 124. You can just do the work. What I mean by that is these questions right here. I just need an answer. These ones. Okay? I'm going to keep recording. And all pages 122 to 124 are going to have the answers. On the video, you can check it. Okay?
What do you do with these questions?
Distribute, do the exponent laws. Yes. Mm-hmm.
Mr. Myers,
Yes.
from the review, there's a problem, and it's a dice rolling game, and there are 8 contestants. If a number is rolled off, then the contestant must leave the game.
Okay. So there's 8 people rolling their dice, right?
Yeah, each
How many are
person.
going to be gone?
You never know. 7 people are going to be
7
off.
people are going to be gone? You can roll even or odd. What's the chance?
50%.
Right. So how many people are going to be gone after the first round? You can't see the future, but how many would you guess?
You never know. Or
Of course you don't know. It's a guess.
50% maybe?
Right. So how many people are gone after the first round?
4,
Okay. How many people are gone after the second round?
2,
How many people are gone after the third round?
1,
So that is your winner. How many rounds did it take?
4, 3 rounds.
There you go.
Oh.